Hello, geometers. We're going to look at congruent figures today. And remember what the word congruent means. It means these are the same shape and the same size, which is why we have things in the world like clothing sizes, shoe sizes, because if they're the same size and same shape, they ought to fit, right? All right. Um, Real quick, hopefully you remember that this little symbol here means congruent. So if we know what congruent means, they're the same size and same shape, and we know what the symbol for it is, we can start talking about congruent figures from section 4-1 in our books. So the first things we need to talk about is like, what is it for people in geometry and for mathematicians? They need more proof than for somebody to just say, oh, these things look like they're the same size and the same shape. We need further proof. So if I were to say that these two figures were the same, that's got some very specific meaning. And the first term we want to make sure you understand is corresponding. What are corresponding parts? Corresponding parts are the ones that match up. So, for example, if I did say that these two figures were congruent, then that really means that the corresponding parts would have the same measure. So, I could say that segment KH, and remember when I write segment, I use the end points for the name and I draw the segment symbol above it. That means segment KH. And again, this is my congruent symbol, so I'm going to say segment KH is congruent to its corresponding part, which would be segment ON. So I'm going to write its name ON with a segment bar above it. Again, you guys kind of fall asleep when I do this, and you just go, I'm not paying any attention because my brain's smart enough to know that further in the future. And then you take a test and you get it wrong, and you're like, but, I can look everything in my life up on the internet. Why would I need to remember something? Well, remember this, because we use it the whole book, and it would be nice if you would know how to name a segment and what the congruent symbol is. So remember these parts, right? So anyways, I'm going to match these up and say, you know what? These two parts correspond with each other, so they have to be congruent. And I'm going to list those. I'm going to list more than that. We're going to continue to do this and go, all right, let's match up this segment, which is HI. So again, I'm going to name the segment HI. It's got a little symbol above it for a segment. I'm going to use the congruency symbol because, yes, these things are important to understanding and communicating geometry. And I'm going to write segment MM with a segment symbol above there. Okay, so I know those two segments are the same or congruent, right? And we'll continue. Let's do segment IJ. Again, write I and J and put the segment symbol above it. And that is going to be congruent. Yes, we use the congruent symbol to what segment in the other figure? Yes, that's congruent to ML. So we're going to write ML with the little symbol above it. And finally, my last segment that my last pairs of segment that correspond with each other would be segment JK. So I'll write JK again with the segment symbol above it is congruent to what? Segment LO with a little segment above it. So here's a nice listing of the corresponding sides, but let's not stop there. Let's do the corresponding angles. Remember how to name an angle? Well, this one's not going to be too bad because I don't have any confusion. I can name these with just one letter, but the angle symbol is a little tiny angle, looks like that. So I'm going to say angle K, and again, I'll use the congruent symbol. Angle K is congruent to which angle? Once again, we're talking about corresponding parts. So angle K would be corresponding with angle O. So I'm going to say angle O here. That's one pair of angles that correspond with each other. What's another set? Well, I'm going to go counterclockwise as I go around here. So I'm going to talk about angle H is congruent to angle what? Yep, it corresponds to N, so they have to be congruent. And then I can say angle I is congruent to angle, you guessed it, it's angle M up here. And I'm going to continue around and say now I'm up to J, so I'm going to say angle J is congruent to angle, angle L. Okay, so I think I've got all those. I've got my 1, 2, 3, 4 angles listed as well. Okay, now all together we could say that this figure, and I'm going to name the first one K, H, I, and J, is congruent to, and then I've got to list these in the correct order as well, starting with the ones that correspond. So what one corresponds to K? Well, that would be O, so I'm going to write it first. And the second one's got to correspond to H, so I've got to write N. And the next one has to correspond to I, so I'm going to write M. Order matters on these. When you say two figures are congruent, the corresponding parts have to be listed in the right order. The last one here is J, and it corresponds to L. So when you write a congruency statement about two figures, they better match up. That is, that if the first letter K here is where we're starting on the first figure, then its corresponding vertex O must be written first here. And if I write H second, then its corresponding point must be written second for the second figure, okay? And if it comes third in the name of the first figure, then its corresponding part must be listed third on the name of the second figure, and so on and so forth. So make sure that these points, right, all have their corresponding parts listed in the same order over here. That's important. So real quick, congruent means that we're going to have the same shape and the same size. The congruent symbol looks like this. If two figures are congruent, then their corresponding parts are going to be congruent, and we could list those. Segments are named with two letters and a segment symbol above them. Angles are named with the angle symbol, and in this case, just one letter, right? Because it's clear which angle I'm talking about if I'm talking about angle K. If it's not clear, we might have to list angles with three letters, but we lucked out in this particular figure, and we could do it with one letter for each angle. Okay? Okay. Let's take a look at something, an example from your book. I'm going to start with the example, and it's right here. It says, are the triangles congruent? If they are, we've got to check all of their parts. And so how many parts are there to these triangles? There are three sides in each triangle. So that means that I'm going to have to match each of the three sides of one triangle with each of the three sides in a different triangle. So let's take a look up here. AB is congruent to which side? And this little tick mark here gives us an indication as to what side we're talking about in this triangle that's over here. So AB is congruent to ED. That's what those little tick marks mean on the sides, that these two sides, AB and side DE, are congruent to each other. So I've tested one side against the corresponding side of the other triangle. Let's look, because they've got measures now. It's telling us that segment BC is 4 units long. And in the second triangle, I can see that segment CD is 4 units long. So those sides have the same measure. Review. I know side AB has the same measure as side DE, and now I know that side BC has the same measure as side CD. So now I have two sides in one congruent to two sides in the other, and I'm moving right along. But triangles have three sides, so let's test that third side to see if it's true there as well. This side, AC, has a length of 6, and I can see that its corresponding side in the other triangle also has a side that's 6. So that gives us three sides. If I can get my thing, everything's backwards when I'm filming myself. Three sides in one triangle are congruent to all three sides in the other triangle, and so we're halfway there. Because remember, when we look at the corresponding parts, we should look at the sides, right? Make sure that all the sides have the same length. But then we have to go back through and make sure that all the angles have the same length. And if that's true, then we could make the statement that the figures are congruent. In this, we've made sure that all the sides are the same, but now we should go back and make sure that all of our angles have the same measure. So let's test. Angle A corresponds with angle E, and we can see from the diagram by these little angle marks here that these two are the same. So that little arc piece there that's on A and E are marking A and E as congruent. So I know angle E and angle A are congruent, and so I have one angle in one triangle congruent to one angle in the other. Two more angles to go. Angle B is also marked to be congruent to angle D. Okay, B and D correspond to each other. If these were congruent, those would correspond with each other. So let's make sure that they have the same measure, and they do. So that gives us two angles in one triangle congruent to two angles in another triangle. And let's check the last angle. Can I say that angle ACB, right, that's this angle that's right here, can I say this angle is the same as the angle on the other side over here, which we would call angle ECD? Is angle ACB the same measure as angle ECD? Yes. Do you know why? Starts with a V. They're vertical angles, and we know that vertical angles are congruent. So we can say that the three angles in one triangle are congruent to the three angles in the other triangle, and that gives us all of the corresponding parts congruent. Therefore, we can say the triangles are congruent. Notice that they've written the congruent statement down here that says triangle ABC is congruent to triangle EDC by the definition of congruent triangles. What is the definition of congruent triangles? It just means that the two are the same size and the same shape. It means all of their corresponding parts have the same measures. Okay, and we just confirmed that. We checked to see, is AB the same as ED? Yes, it was. Is BC the same length as DC? Yes, it was. Is AC the same length as EC? Yes, it was. All of those segments were congruent. And then we went back and checked to see if the angles were all congruent to each other. And we said, well, angle A was congruent to E, angle B was congruent to angle D, and we knew that angle BCA was congruent to DCE because they were vertical angles. So we were then able to determine that all three angles of one triangle were congruent to all three angles of the other. Therefore, believe it or not, we checked 6 different things because each triangle had 3 sides and 3 angles, and we had to check all 6 of those against all 6 of the other triangle to make sure they were congruent, to give us a statement that said, yes, they really are congruent. And here's that statement. Notice again, just highlight that A and E would correspond with each other, right? Their corresponding parts. B and C would have to correspond with each other, their corresponding parts. That means they're the same, right? And angle C and angle C and the were these C's were the same too, right? this angle C was congruent to that angle C because they're vertical. So their corresponding parts match up. Groovy? Groovy. The next thing that your book says is maybe we can do this a little shorter. And so what it says is this. Because if I add up all of the angles, what are called interior angles of a triangle, their sum is 180. If I knew two angles in this triangle and I knew two angles in this triangle, I could conclude that the third angles here would have to be the same measure as well. And that's just what it says. It says if two angles of one triangle are congruent to two angles in another triangle, then I can say those third angles must be congruent as well. Okay. And there's a nice proof in your book if you'd like to look through it, because I know you love proofs, that'll tell you without any shadow of doubt that that statement is true. If two angles in one triangle are congruent to two angles in another triangle, the third angles must be congruent as well. Because you know what? They add up to 180. So here's a proof that says, hey, can we prove that two triangles are congruent? Yes, we can. Let's just cover up what they're doing first and see if we can think about what we would need to do to prove that these are congruent triangles. And they're starting off by saying LM is congruent to LO. So we got their little tick marks there. So those sides, those corresponding sides are the same. And then they say MN is congruent to ON. So these corresponding sides are also matched up. And then it goes by and says, well, you know what? Angle M and angle O are congruent to each other. And angle MLN is congruent to OLN. So these two angles are congruent. Where do you suppose we're going to go? Well, the two things that we don't know, because remember, we have to have 6. And if I count these, there's 1, 2, 3, and 4. 2 of them are missing. If I've got to prove all 6, right? All 6 pieces of one triangle congruent to all 6 pieces of the other triangle, I'm missing 2. And the 2 that we're missing are that this angle over here at N and this angle at N must be the same size as well. Do you know why they're the same size? Yep, the theorem we just looked at. If two angles in one triangle are congruent to two angles in the other triangle, then the third angles must be congruent to each other too. So somewhere in this proof, they're going to match up those angles and say they're congruent by that theorem. And the last piece of the 6 that we would need is to say that Ln is congruent to itself. And it is. What property gives us that? Well, that's called the reflexive property. So if you look through this proof, we'll just kind of step through. They're going to say, okay, let's look at the sides that we were told in the given, and we'll list those. And then we'll say the third side of each triangle is congruent because it's really just the same segment. We'll use the reflexive property to show that that same segment is congruent to itself. Okay? Then they're going to go through and start looking at angles. And so they're going to mark the angles or tell us about the angles that are marked off up here. M congruent to O, and then MLN to OLN because they were given. And what I said before is we would then need to show that this angle N and this angle N are the same size. And how can we get there? Well, we can get there because of the third angles theorem that we just said. If two angles in one triangle are congruent to two angles in another triangle, then the third angles must be congruent as well. Okay? So once they've got that, they have all 6 parts of one triangle are congruent to all 6 parts of another triangle, and therefore those 2 triangles are congruent by the definition of congruent triangles. Okay? It's just that simple. Proofs aren't hard. You just have to think a little bit. Let's look at some of your homework questions that are in here just to make sure we're on the same page. Up here, it's asking us to list the congruent corresponding parts. How do we do such a thing? Well, you sharpen your pencil because you're going to have to do a little bit of writing. What I started off with here was to say, let's list the corresponding parts that are congruent. And I did. Here was a four-sided figure congruent to this four-sided figure. So I had to write four different congruency statements that talked about the sides using their names with a segment above it because each one of the sides is just a segment. So I had four statements like that. Okay. Then I went back and I told about each corresponding angle pair, right? So you're going to have for four-sided figures with four corners, you would have to write four congruency statements for each vertex. That's the pointy part that is at the end of the segments, right? K is a vertex, H is a vertex, I is a vertex. So we're going to have to match up the angles here and have four statements there if you have four vertices. Okay, so you can sharpen your pencils and get ready to write that. For each one of these, it says go ahead and write a list of the corresponding parts, just like we did here. Okay, and then you'd move on and say to these problems, it's telling you what? It's telling you that this triangle is congruent to that triangle. If that's true, then LC, and I don't even have to look at the figure over here, I can just match up the parts. What I mean by that is L is the first letter, C is the last letter. If that segment LC is congruent to something, it better be congruent to segment BK because B is the first letter and K is the last letter. L corresponds to B, C corresponds to K. What goes in the blank? You better write segment BK. How do you write a segment? Well, you write the letters B and K and you put a little line over top because it's a segment. Segments can be congruent. If you just write BK and you don't put a segment over the segment symbol over the top, you're not doing it right. Because if you just said BK, you would be talking about its measurement. Measurements are equal. This symbol is congruent. Only segments can be congruent. Make sure you understand the difference between the congruency symbol, in which the names are used, and the equal sign in which the measurements would be used. So there's a difference, right? Okay, skipping on down the road, like look at number 13. It says angle L is congruent to which angle? Sure, you can look at the picture, but you don't even need to. L is the first letter of this figure, so it's got to be, its corresponding angle has got to be B. So angle L would be congruent to angle B. Again, don't just write B, write angle B. There's the angle symbol, right? That's angle L. So anyways, go through those. You can write the appropriate names down and fill in those blanks. Down here it says an archaeological site that remains two ancient step pyramids are congruent. If one of those is congruent to the other, find each of the following. Diagrams not necessarily to scale. Again, once again, AD. Now, there's no segment symbol above here, right? So it's talking about the measure of AD. What is the measure of AD? Well, I know from the way that they're listed that AD matches to EH, and that EH in my diagram is 335 feet. So where it says AD, I write 335 feet because this question is asking for its measurement. How do I know it's a measurement? There's no line segment above here. When it says AD in this case, it says the measure of AD. So 22 is asking for the measure of AD, and we know that AD matches to EF, which is 335 feet. So AD has a measure of 335 feet. Again, these questions are asking for numbers. How do I know that? Because it doesn't have segments above the letters, and it doesn't have just the angle. It has got a little M in front of it. And when you see a little M in front of your angle sign, it's asking for its measure. M stands for measure. 24 is asking for what the measure of angle GHE is. And since GHE matches to CDA, I can come over here and look for where is CDA. And I think CDA, C must be at the top. CDA must be this angle, which is 52 degrees. Okay? Groovy. Anyways, just to review, these up here are asking for names. So you're going to put segment symbols or you're going to put angle symbols. These down here are asking for actual numbers for measurements. Can you conclude that the triangles are congruent? The only way to conclude the triangles are congruent is if you can show that all 6 measurements on one would be the same as all 6 measurements on the other. If any information is missing, you can't say. All right? Think the rest of them should be pretty straightforward. The assignment is listed. Please work on those problems. Have a great evening, and hopefully we'll talk at you soon. Bye-bye.